Hello and welcome to another Solana tutorial. Today we're finally gonna do the thing that I've been talking about for the past 6 videos, which is we're finally gonna build a Pinocchio transfer hook. And the goal of this is to have a somewhat efficient program. That's why we use Pinocchio and not Anchor, because we want to be compute efficient. And also we want to learn about Pinocchio and how we can do that. This shouldn't be too complicated. But I just want to do it to see what are the issues. What is it that we're going to struggle with? And get over it. Find solutions to that. Because in my head, this is super straightforward. Just write the Pinocchio program and we'll be done in 15 minutes. However, reality probably makes it more like 45. We will see how long this is going to take. Let's just get started. So motivation is do a simple transfer hook with a Pinocchio program. And by simple, I mean it should still be able to do something. Let's start with doing the same thing that we did in the previous video or in part 3 of this series. Because transfer hooks, I just kind of like it. I also don't, but also, we're deep diving on it. So let's write a Pinocchio program. And basically, this is what we had in the previous video where we did some anchor optimizations, which is the step before what we're doing now. Now we're just doing even more optimizations by rewriting the whole thing in Pinocchio. But this is basically what I want to be able to do. I want to be able to do a simple hook that asserts that at least one token is being transferred. Because then we work with input data and we work with account data. That should be sufficient for you to get the idea how all of this is done, and you can make a more complex example as you see fit. Maybe we also do this asserting, we'll see. So basically I want to rewrite this program here to a Pinocchio program. Let's go. So let's do p hook and cargo init ellip. Okay, and then cargo add Pinocchio. That's what you gotta do to create a Pinocchio program. We know this because we have videos on this. Let's open this. Are we gonna do regular entry point or are we gonna do lazy? Let's do regular. Makes it a bit easier. We don't wanna go like super hardcore optimized. Besides, most of the accounts we will need to use them anyway. And we need to have the instruction data, so we'll need to pass that anyway. So we'll need to go through the accounts anyway. And the lazy entry point is not always more efficient, just if you're not using the accounts. Yeah, I think I'm good with that. Let me just see if I can build and deploy stuff like that. We will need to be able to cargo build SBF, a classic. Consider add cargo features to your, okay, sure. Above the package, sure. Edition 2024, sure. Developing in Rust. There it is. Lib this crate type, such that we get the target deploy with the SO file. Build again, then we should have the deploy with it. Perfect. I do want my own key pair. So Solana keygen grind me a P hook. Behold, it's a key pair. And we copy this to target deploy key pair. Cool. And this guy doesn't know what key it is. That's fine. It doesn't check that. Okay. Can I do... Wait, am I rich enough? It's a Pinocchio program. Yes, I'm rich enough. Solana program deploy. The target... Oops. Try that again. The target deploy P-hook. 4 transactions. There we go. It's a Pinocchio program. It's small. Wonderful. Love it. P-hook is deployed. Nice. Works for me. Cool. So let's write the actual program, because essentially we want to do this. And the first thing that we got to do is check if it's the actual right instruction that is being called, because there could be different instructions being called on our program. Is it this execute instruction? And we did have a look at those discriminators in part 2 of this series, but for now, what we can do, of course, is pretty much like the fallback that we had in part 1, let everything map on the transfer hook function, basically. So let everything be the transfer hook, as if the program just handles the transfer hook. It will need to handle more things, but we could, for instance, instead of checking all 8 bytes of the discriminator, just check the first byte, or only for specific other discriminators, check for those first, and if it's not any of those, then we know it's our transfer hook. or it should behave like it's being called as a hook. And I think that's actually the most efficient version, because why would I need to compare 8 bytes if otherwise I would just error anyway? Might as well pretend. Like, it's a question of what you want, right? Do you want to make sure that it's being called as a transfer hook? Yeah, then maybe check that. But if somebody else calls my program with whatever instruction data, I don't really care, which in my case, I don't really care. So let's not care. Let's pretend everything is transfer hook. So as soon as the program is being called, we pretend or we assume that we're in the hook, and we're gonna deal with those things later. So what we want to do is check if the amount is at least one token, and then we say okay, otherwise error. Okay, that's not gonna be too difficult, right? Because we get the instruction data. It's a slice of U8. The first 8 bytes is the instruction discriminator, and the second 8 bytes is the amount. So let the amount be a U64 from little endian bytes, instruction data 8 to 16 bytes. There you go. That's what I need to do. Because it can't be sure that it's actually 8 bytes, but I'm sure that it's 8 bytes. And if I don't get enough instruction data provided, well, then we're just gonna fail here. And I'm like, yeah, whatever. We could do a nicer error. We could do wrap or else. How did they go with map? I want to map the error, try into, I get a result. I can just map. I just map the error, maps result from this error to this error, and leaving the OK untouched. Yeah, that's what I want. The error I want to map from whatever it is to a invalidated count data. What are you? An error. But this is a U64. Program error invalid instruction data. That's what I wanted. Which is a program error. And then this, I question mark. And then I do from little endian. That looks about right. Why is the entry point yellow? Nobody knows. I'm not ever gonna read the program ID, so I will read accounts later. So should we check if that's working? I don't know how to spell it. Transferred. Oh yeah, and for that we will need the specific log. What was it? Pinocchio log, which is gonna add that temporarily so I can do debugging, write messages. Cargo add Pinocchio log. We'll remove that again. Maybe not, who knows. But I want to be able to do this. So log, Pinocchio log. There you go, no message. Let's see. Cargo build SPF and cargo deploy. We'll use it eventually, don't worry. Now we need 9 transactions, wow. And now we somehow gotta test it. We could either run it ourselves, or I guess we gotta run it ourselves for now, because we don't have the account set up for that yet. Let's just call it ourselves. I'm just gonna borrow one of those scripts, simple transfer. That will do. New folder, app stuff, simple transfer. Direct hook call. Hook program is this. Don't need all of that stuff. And all we're doing, so program address is my hook program. Accounts, we don't need any. Data, also don't need any. Ooh, panicked. But we managed to call the program. Oh, yeah, of course. Why does it panic? That's exactly what we said here. We are accessing areas that we should not access. So maybe we should, if we don't want to see it panic that like crazily, maybe we do want to do it a bit nicer. Also say get here, get 8 to 16. And then also here I can... Wait, what do I get back here? An option, not a result. Okay, so if that is map, well, I'll just end then. So not touching the none if it's a none. But if we have a slice here, if we have this slice, then I'll say slice try into. So I don't do this out here. And then that gives me the option or a result. So I should get none or a result in this option. So I don't map error. Rust is not so trivial. I get an option. So we say this is either okay, or if it's not okay, it's this error. And then we throw this, we raise this if it's that error. And otherwise we do the from little endian bytes. There we go. That's clean now. Maybe not super easy to read, but maybe also not the super nicest, because here we pack it into an option and then we unpack it again. Shouldn't that be here? Program error. Then raise this. And then I have to slide right into... Maybe that's cleaner. Now, whatever. Let's just make it work. Just build it and deploy it. And then let me run it once. Does it panic again? No. It fails with invalid instruction data. That's much nicer. Okay. Good. Can live with that, because now we neatly say invalid instruction data. Good. Well, then let's provide the correct instruction data. We said we don't need instruction data, but we do need instruction data. We're not even gonna do the correct discriminator, even though maybe we should. But for now, 1, 2, 3, 4, 5, 6, 7, 8. And then let's transfer 42 tokens, whatever that means. 2, 3, 4, 5, 6, 7, 8. 42, milli tokens, or 42 tokens if it's 0 decimals. Let's try that. There we go. Amount being sent, 42. So that works. We can read the instruction data, AU64. Cool. Now the next thing that we're gonna read are the decimals, so we get that right. Because the 42, we can't check if that's more than one token now because we don't know the decimals. So we need to read the decimals from accounts. And we know, or we assume, that we get the correct accounts provided, and maybe we should do checks on that. Maybe we should say, actually, because we expect that it's the transfer hook, if accounts length is less than, do we expect the extra matters as well? No, let's say 4. We want at least 4. Then we error with program error, invalid count, or account, not enough account keys. That's a good one. So we know we have 4 accounts, so we can just say my mint account is account 1, because that's how we expect them to be provided. And my mint account, I can just read the data. I'm just gonna borrow the data, try borrow data. And then I just unwrap. At some point, this is gonna just work because the borrow checker will be fine. I want the mint account data. And we said at byte 44, can I just access that directly? I guess so. And just for my debugging purposes, this token has so many decimals. Let's see if that would work. So we will need to actually provide a token mint now. Do I want to create a token already? Sooner or later, we will need to create a token anyway. Or let's do Pinocchio hook token. Honestly, Pito does sound nicer. P token with a hook. Yeah, I'll take this. And I will do SBL token create token with program 2022 with transfer hook, the Pinocchio hook program, and decimals. Which token has 5 decimals? This one. And what else do I want to say? Create token, of course. Token. There you go. 5 decimals, that's the token. And I'm gonna SBL token create account for this token. That's the account. But really, that's not so important. For now, I just need to supply this anyway. But so we could do it the correct way already. Let's provide the source token account would be this. And all of that is just going to be read-only for the program anyway. So I need 4 accounts. And the second one is going to be the mint itself. And the others, I'm just, for now, I leave those in. Because, whatever. We'll deal with this later. And then we're going to rebuild and deploy and see if that actually works. That it tells me the correct decimals of this mint. Will it? Yeah. This token has 5 decimals. That works. Easy, we can read the decimals. So we can continue and do the actual check of the transfer hook, which is if the amount we transfer is less than this 10 to the power of decimals, then return an error. Which one? Program error, custom. And custom, we transfer too little, ITTLE. We'll do this, whatever. So I guess that's already that check. And otherwise we're okay. So deploy me this, and then let's do this. And this should fail now because we're transferring 42 tokens. There you go. We're transferring 42. We have 5 decimals, so that's less than 1 full token. So program error 0x1cbd1, because apparently that's that. Nice. And if we were to transfer more, I don't know, let's do, a shit ton, then it would be success, because now with 1, 2, 3, 4, 5 decimals, we're still transferring 42,000 tokens. And the 42 here is a coincidence. That's actually 42,000. It doesn't have to do anything with those 42. Those 42 are just those in the end here. If I would do 38 less and have a 4 here, then it would be 0, but still 42k. Anyway, we'll see. 42 just is the answer to everything. Anyway, so yeah, that seems to work. Should we also implement the check if we're currently transferring? because then we can't do it with this script anymore. Then we would need to actually be calling it as a... Yeah, why not? But we're going to work with the same assumptions that we did in the previous one. Or should we do it nicer? Let's do a proper implementation for it. Here we just worked with the assumption that it's at this location, but we can do better. And we don't want to write a program that works on a lot of assumptions. We want to write the program that actually properly works. So let's do better than this. Check if we're actually transferring. Let's check it on the source account, which is account 0. Get the source account data. And from that data, let's look at such an account. Because the offset until the extensions, I think, is fixed. Now, if we have a look at such an account, the offset to here, I think, is fixed. So that would be... Wait, the offset to here, I think, is fixed. And I think... No, wait. This must be it. Yeah, no, this must be it still. Should we look at it? Mint and the account... We have 32, 64 plus 8 plus 36. What's account state? That is just 1 byte plus 1 plus 4 plus 8 is 12 for the C option plus another 8 plus another 36 for this C option pub key is 164. Would that make sense? 164 in hex is A4. And if we look at that account, A1234. Still missing a byte. 32 plus 38 plus 4 plus 32 plus 1 plus 4 plus 8 plus 4 plus 32. 165. Yeah, that's what I said. 165. So that's A5. Yeah, there we go. That's my issue. So A12345. So that's the offset. And there come the extensions. After those come the extensions. So this is 165. We can assume, because that's the interface definition, we can assume, and this is not an assumption, this is like, we can assume, like it is the case always for token accounts that the extensions start at 165. So in our program, offset is 165, U32, whatever. Or make it a, actually, should make it a U size. So number of extensions is source account data at offset. And then we could say this token account has so many extensions. Should we prove it that it's 2? Just real quick deploy, because that's quick with Pinocchio as well, because it literally takes 5 transactions to deploy. Much nicer than with Anchor. 24? Oh yeah, because I have so many dependencies. Anyway, if I now call this token account has 2 extensions. There we go. So this is working. We're counting the extensions. And now we need to find the extension number 9, I think. No, 0F, number 15. This is the extension we need to find. So we just read 1 byte of, so let's do while let I be 0. Okay, let's count through extensions. At most we go through the extensions. And we read the extension discriminator. Well, first, I'm going to say I add 1 to the offset, and then I read from the offset. This is the extension. If this extension is extension number 15, so that's the transfer hook. I should make a transfer hook extension discriminator 15. That's the 15, that's the one we're searching for. So if we have that extension, great. We know the length of that as well. You know what? Maybe I should make a function for this. Because here I can then say offset another byte for the extension, another 2 bytes for the length, and then I get to my boolean, let transfer flag be this. And if my transfer flag is 1, then I can say we're currently transferring. And else, invalid account data. Now, let's do a custom one. Let's do, we are currently transferring. I'm not creative. Foo. Yeah, that's it. We're not transferring. That's the flag for it. Usually you would do a named error and then whatever, and then you can map that. But whatever, which is, as long as we error, I'm happy with that. So we also want to error if we don't find the extension. If we're not transferring, we throw that error as well. Maybe with a 1 here, so we see it's a different one. And then when we say we're currently transferring, we set transferring to true. This would be a bit nicer with an actual function, but it works like this as well. I do want this error now, not this one. If we get to this one, then I made a mistake. If I get this one, then it's correct. Let's see. I made a mistake because obviously what I didn't yet implement is to step further every time I read the extension. So if it's an extension that is not that, here else we need to add to the offset as well. Offset plus equals the one that we have for the, because there are 2 bytes of extension discriminator really, but we're just reading the first one. And here I need to read the length, which again I should read 2 bytes, but I'm lazy, so I'm reading 1 byte. So far I don't know an extension that has more than 255 bytes, so I guess it's fine to just read 1. Then I just say offset plus equals 2 for the length plus the actual length as usize. There you go. But then it should step forward and also find the other extension. Will it or will it not? It will not. Still not. God damn. Oh, because that didn't work. Damn, am I broke again? Why did you not deploy? Just didn't manage? Okay. Okay, but now. Here we go. F0. Because we are not currently transferring. Okay. So I have the 2 checks in my program that I want to check that we're transferring more than 1 token and then we're actually being called from the hook. Could do more checks, but those are the ones that I want right now. To assert that it's actually being called from the hook, I would need to make sure that we're actually being CPI'd into. I could either do that with the instruction sysvar, but that is overhead, or I also check that the mint and the token accounts actually work together. Essentially, that those are actual token accounts. The least I can do, let's at least do some owner checks, because that will already add a lot of security if I check that it's owned by token 2022. Owner check. If source account owner, which is a pub key. Somehow I will probably hardcode token 2022 in here. Or do I have it somewhere? Is there a Pinocchio SPL or something? Program as token 2022. I don't need all that stuff, but it would have the Pinocchio program. No. Basically, that's what I want. Get access to this. How do I add this? Or should I just do this once? But I don't want... Doing this takes compute. I just want the bytes. Cargo token. There, that's what I want. Pinocchio token 2022. Can I just cargo add this? And then say Pinocchio program, no, Pinocchio token 2022. That's just an add in here? The hell? You know what? Just gonna hard code this here because whatever. Fine, do it once, create me a pub key. This is not clean, like it's not nice because you don't want to do this in the function call, but somehow you need to get this pub key. And I think this from is somewhat efficient if I just provided the bytes. We're gonna pretend that I found a better solution to get this actual program ID, maybe from another creator or whatever, but I didn't, so let's just hard code it because it's gonna be enough for our purposes. Let's compare with this, the owner with token program ID, and if it doesn't match, then we throw another error, provided owner is not allowed. There, that's even better. And I mean, we could do this for all of the accounts actually, while we're at it. And why this helps us, maybe I should point that out. Because the attack vector I'm trying to avoid here is somebody just providing me an account that has the correct, this data, but is not actually owned by the token program. Then, you can have whatever data here and you can spoof that we're currently transferring. However, when we check that the owner is the token program, then we know that it is an account from the token program. If it is owned by the token program, we can be sure that it's a token account or a token mint or some multisig or whatever. But the chance that it's owned by the token program and randomly has the correct data is much lower than the chance of having any account. And the point of this is just to support the check of whether or not we're currently transferring. If we're not really interested in that and we're like, yeah, if people call the hook and it fails or doesn't fail, it doesn't really matter to us, then that's fine as well. But if we had some statistics running here, then we want to make sure that's only actually being called with accounts from the token program and with this flag set. So yeah, doing those owner checks is actually probably a good idea. Let's do all of them for the mint, the source, and the destination. So that's account source. Destination account is number 2 then. So we do this for the mint as well and for the destination account. Those 3 owner checks, we should add them. Cool. Owner checks added and transferring checks added. Let's see if that works. Build and deploy. I pretend this is a constant. That's why I keep it that way. Okay. And if I call it, it should not complain because I do have the correct program. but provided owner is not allowed. I'm failing even though, maybe I should do that. This is actually a slice of U8s. Maybe that's why this is not working. It remains a slice of U8s. And this thing here is a pub key. What's the definition of a pub key? That is a slice of U8s. Wait, but if it's slices, then maybe I don't even need the equal. Okay, do you think we get illegal source or illegal mint? I hope we get illegal mint, then, because that would mean that then works. Still illegal source. Maybe ChatGPT just hallucinates them. I'd never check that. Let's do it here. So this is the owner, and then we encode that. That looks right. Oh, but it wasn't. The 6 was right, but then it was bullshit. What did it give me here? See, don't trust ChatGPT on doing that correctly for you. You know, whatever. It was the wrong program ID. See, that's why you should take that from libraries that provide it, but I didn't find it, or I was too lazy to search, really. Try that with the correct program ID and then run this. Now, that actually looks good. Both of them work. Like both ways, how I did the check with the directly comparing the two slices or the dot equals. Both of that works. So this and this both works. None of them give me the illegal owner anymore. And then I fail somewhere down here. Cool. So that's working now. Perfect. For consistency, I should do the same, but I'll leave it like that now, such that you see that both is possible. And now with those owner checks, I'm actually fairly happy. Actually, leave this in for now. Let's just do a double check that it would actually work now if I had a different program. For instance, if instead of the actual mint, I would provide some other account, I would provide something that is not owned by the token program. Then I should now get the fail for the source. Yeah, illegal source owner. Only if I provide an account that is actually owned by the token program will that work. Awesome. And then I failed because we're not currently transferring. Cool. But that's good. So that works. I'm happy with my program here for now, at least with the hook part, which basically anything is a hook now, I said. I ignore the discriminator for now, which I can't do long term because we will need to have the program do something else now, and that is create that account for the extra metas. Unless we just want to do manual transfers, but we can't do it with a CLI. And I want to be able to do it with a CLI. So basically what we got to do now, it's not with 15 minutes, forget 15 minutes. 45 if we're lucky, is we gotta implement this initialize extra account meta list function that we had in Anchor that basically creates this account for us, even if it's empty. So yeah, let's do the same thing. If we have a discriminator of 1, then we initialize extra metas. So if instruction data 0. And yes, I let it panic if I have no instruction data. I'm okay with that. Fine, let's do something like that. And then okay, or if that is equal to 1, can't compare, why not? What's this? We get a reference to a U8. Oh, we need to deref it, of course. So if the discriminator is 1, then init extra metas account return. Okay, yes, having everything in one huge process instruction is probably also not the cleanest way to do it, but I'm lazy. I'm just gonna put it in here. It's fine. So what I need to do is call the system program, and that there is a Pinocchio thing that lets me do that. There are Pinocchio helpers for that. System, Pinocchio system, create account. Let's see how we can do this. So first of all, cargo add Pinocchio system. Then we should be able to use Pinocchio system. Here, this has the ID. Why didn't the token 2022 have that? Instructions, create account, not with seed. Nope, just create account. And yeah, I think I'm gonna make a different one now. Gonna make a process init extra meta account. And then I'm just gonna return process in. Wait, you don't need the program ID. This is useless. You also don't need the instruction data anymore, but you do need the accounts. Here, have the accounts. Good. So that's for discriminator 1. And in any other case, process transfer hook. Okay, so for this to work, we will need a few accounts, like we did in our Anchor program, where we neatly had the signer, the extra account meta list, the mint, and the system program. And I will need all of that information because I will need to derive that because I need to provide the seeds. So yeah, we're gonna do the same for accounts, the person signing, because somebody gotta pay, extra account meta list, mint, and system program. So let signer, now let's call it payer, because I will sign, my program will sign to the system program. There's gonna be account 0 in this case, and then 1, 2, 3. We have the extra metas account, the mint, and the system program in that order. It's a random order that I define, but it's my instruction, so I will need to call it correctly. And then we just create account. And that I can then invoke signed. Perfect. We'll do that. From, how does that go? Wait, how do I do that in Rust? Okay, from the payer, I think, to the extra account metas. Lamperts, oh, gotta calculate that. But again, I just need to have enough. It's not like that needs to be exactly correct. Same with a space. It's like, you need to have enough. I don't think that it's a problem if I have too much. So I'll just, use too high values here and be like, how many bytes am I gonna use? 8 plus 4 or something like that. Actually, I think 8 bytes is enough. No, I have a discriminator of 8 bytes, so it's 8 plus 8. We'll see. And then rent for 16 bytes is how much? Yeah, let's say 0.001. That should be enough. 1, 2, 3, 1, 2, 3. That should be enough. Size. And the owner is gonna be me, right? Maybe I do want to use this. I'm not doing this correctly. There is certainly something that I'm messing up here. I do need to label them. From, to, Lamperts, space. What else do you need? Owner. And then I can invoke this sign with the following signers. How does that work now? That's Pinocchio specific. Is there a Pinocchio example program? Pinocchio guide. Invoke signed with signers. Yeah, that's what I want. But that's Solana program again. That's not even Pinocchio. Why does the Pinocchio guide have all this program? This is BS. Cannot take this seriously anymore. Pinocchio scroll. Invoke signs, seeds, clone. Seeds is what? Signer from seed. There we go. Something like that. There we go. So we do a signer from seed and seed from seeds. Perfect. So now we just need to put the right seeds. First, extra account metas, then the mint key, and then the bump. So the mint key and then the bump. But the bump should provide that as instruction data, because otherwise I'll need to derive it myself in the program. Man, I don't want to do this, but I guess I'll do this. Yeah, here it does find program address as well. Well, fine. So I'll need to find program address, the seeds, the program ID, and it will give me the pubkey and the bump. Okay, let's do the seeds like this. So first without the bump, those are the ones that we put in here. And with our program ID, we find this, which should give me a pubkey and a U8. So let extra pubkey, extra bump. I'm getting lazy with the typing. Here you just want the U8 slice. Okay, fine, seeds. Is that what you want? Cannot find, yeah, because I call it seed slice now. And this is consider borrowing. Yeah, sure, okay, let's borrow this mother. There we go. There we go. I don't think I need to provide the bump because the bump is what I get out here as well, I guess. So then I get the pubkey and the bump, and then I can build the seeds with the goddamn bump. So then we have the actual seeds, and then we make a signer from those seeds, and then hopefully I can put that signer down here. Does that work? No. You don't like program ID. Cannot find. What cannot find? It's literally here. What's the problem? Oh, program. Oh, I misspelled it. That's why. There we go. Maybe another thing I should do is check that the extra metas account key actually is the same as this extra metas, okay, that we got from the find program address. Because if not, extra metas account key doesn't match. Found this, derived this for debugging purposes. We will print bytes here and not like nice pubkey strings, but that's okay. Pinocchio is efficient, so it doesn't work on the strings like TypeScript would, but it works on the bytes. So it will also print the bytes, but that's fine. Ideally, we don't get here ever anyway. Wait, so what's the problem with the bump now? Probably the borrow. I already temporary values freed at this statement. Bump, slice, bump, slice. There you go. Keep it for longer then, such that it's not freed because I need it down here, the other thing. Okay, Rust is complicated, I know. Okay, but do you think that's gonna work? Can we just create that account? It's fine if we create it like empty and don't write anything to it. Although actually, we should write something to it. What would I write to it? Hold on, I have an example, an old one. This account, for instance. What's in there? It is 16 bytes, as I said. There we go. And that's the discriminator. Don't ask me how it derives that. And then that's the length, which is 4, and that's 0. So we have 0 extra accounts. That's basically what I want to write into my account as well. So after that's done, and I'm the owner, I'd like to write data to account, extra matters account, try borrow mutable data, vibe code. Ah, that will do. Did you take the right bytes this time? I hope so. Cannot borrow data is mutable. Oh, mutable data then. There you go. Fixed it. We just write the exact same thing into this account. You think that's gonna work? The discriminator, I think, is important because this extra account matters discriminator. It's just a thing that we know that it's this type of account. So we just need to write that. And then we write the accounts by the length, how many. That's a TLV, type length value account, and the value is the extra accounts list, and the list is empty. That's what I want. So do you think that's just gonna work? I don't, but I'm gonna try. Cargo build SBF and Solana program deploy. Okay, now before we get started with this, we do have the token. We created an account for it. Let's try and transfer it. SBL token transfer this token, one of it, to a receiver. Yeah, let's transfer to this guy. If I try to do that, oh, right, I have 0 tokens. Let's mint a few tokens then, and then do the transfer. Same thing here. Yes, transfer something there just so that warning doesn't come all the time. Okay, but now, okay, fine. I gotta create the ATA for them. I can do that. There we go. That's what we know. Account not found. Because this extra matters account that we are trying to create here has not been created yet. Good. So let's create it. For that, I think I'll need another script. With this hook program, the discriminator is 1, so that's how it knows what to do. And then we have the 4 accounts of mint as second, signer as first. So gonna put captain here. We're not doing signer checks, but the system program does, so that's fine. Mint, and then we said, and what was the second thing? So we had payer, extra account matters, mint. Okay, so the mint is this. But the extra account, I did that as well already. I'm just gonna look it up. There, move the mint out here, extra matters, mint. And this one will need to be right. Import from guild, import from guild. There we go. So we again do a get program derived address. Here it's called get, not find, but it does the same thing. Gives me the bump and the extra account matters. I can also log the bump just to see we have the same thing. Not like I'm logging it in a program, but whatever. Okay, but that way I should be able to call this. Let's see. Let's do init extra matters. Wow, that worked with success. Extra matters account key doesn't match. Well, if it doesn't match, I should probably error. But interestingly, it says it doesn't match and it finds the exact same first byte. So I would assume, do I have a logic error with the, because if it doesn't match, then I would expect I can't sign with it, but it all worked. So that's weird. I probably have a logic error where I say if it equals, then yeah, goddamn, so stupid. If it doesn't equal, of course, then I should do this and return an error, program error, invalid argument, invalid seeds, maybe invalid argument, who knows, invalid account, not like we care. But yeah, I had a logic error, but it works. I could create this account even, look at that, first try, but it did. Look, I put a bit too much rent on it, but that's okay. The BRB, this is my extra matters account, Solana account this, and it has those 16 bytes and they're written correctly. This all worked. Awesome. So now if I do the transfer again, same thing as before, now it should find that account, but then it fails. Okay, that's fair, but we're getting further. We're currently not transferring. What? Really? Why am I getting this error? Token has 5 decimals. Custom program error. Token has 5 decimals. Then the owner checks all work out. Then maybe I still have a bug here. Found extension. Oh wait, maybe I need to deploy this. Feedback for the CLI. Can you format that a little better? Or is that my responsibility? Or should we just read it as it is here? Basically, we have 5 decimals. We have 2 extensions that it reads correctly. And then first it found extension 7. Perfect. Then it found extension 15. Perfect. And then it ends with that error. Yeah, so it thinks we're currently not transferring. Is that offset wrong? Let me double check that. So what's the account? Should still be this one, I think. So we read this and then we add 1. Oh wait, we read this and then we want to read this. So we need to say plus 1, 2, 3, 4. So there's 3 in the middle, but then I'm still here. And I need to go here. Ah, that's my issue. I'm off by 1. Classic. So it's plus 2. 2 for the length of the discriminator, 2 for the length of the length. And we know that the length is 1, so we don't need to read it. And read the first byte of the length. Then it should be fine. Yeah, my bad. Build, deploy, and... oops. Transfer. Come on. Yes! Look at this. We did do a regular token transfer of our Pito token, a transfer checked that did call our Pinocchio hook program with all of the right accounts. And we did check that all the owners are correct. We did check that it transferred 1 or more tokens, and we did check that it's actually transferring, that it actually has the flag set. All of that with Pinocchio. And did we save compute doing it with Pinocchio? No, we did not. We also need 4,300, but that's just because I'm logging so much. If I were not logging so much, redeploy, then we could get it down to... ah, that looks better. 292. There we go. That's much better. This is what we're talking about here. Much better. 292 versus the 1,700 that we needed with Anchor, even with optimizations here. Without optimizations, we were at 5K here as well. And now we're down to 292, which is more efficient. So it does make sense to write your programs in Pinocchio if you want to be CU efficient. And we did do checks, like we didn't check the discriminator here. We're like, that's gonna be all right. We could check that the first byte is 69, for instance, or whatever. But we don't need to, because we can just always treat it as if we're in a hook. Yeah, I want to do this better. I don't know how. What else? Anything else that I can improve? I can show you that it works. Let's transfer anything less than a token, 0.99. And it's gonna complain with this error code. It's not telling you a nice name here, but we know that this means too little. And if we have 1.99, then it's fine, because it does manage to read the decimals correctly. This is a good program, yo. And obviously, I didn't do everything that I could be doing with transfer hooks. Again, if I want to do anything with additional accounts, then I need to write into the extra metas list extra accounts, the ones that I want, and then I could use them here in the accounts. Should we do that? I think that's just a writing exercise. I think you understand how that works, because we went through it in the previous videos. I'm good with that. We have a working transfer hook with a Pinocchio program that is super efficient at what it does. Checking that the accounts are owned correctly, checking that we're actually transferring, and checking that we're transferring more than 1 token, which is arbitrary, but you know, whatever, that's the goal that we set. I can put whatever logic here. This is my hook program. I can do whatever. I can do other checks here. That's pretty much the same as with Anchor. We have access to all the things. It's just we gotta write it a bit differently, because we gotta work on the raw data, because that's all we get, because we don't have any Anchor that decodes that for us. But that saves compute. That's why we're more efficient. That's what Pinocchio is about. Good. I like it. I'm gonna end here. Thank you for watching this. I really enjoy Pinocchio. It's just so nice, and you can be so efficient with it. And it's not like annoying with dependencies, although sometimes, like if you want, for instance, the token 2022 program ID, I'm like, how do I get that in there? I didn't find a good solution for that, but whatever. it feels a bit more low level, but it also feels like I'm in more control. So that's why I really enjoy Pinocchio. And building a transfer hook is just one of those things that you can do. Or making your program be the hook for a token. That's just fun. A fun little excursion or experiment or exercise. It was a good exercise to do this. Nothing super unexpected that happened. It's fairly straightforward. If you want this as reference, I will put a link down to a GitHub where you find all of this, all of the files that I wrote today, so you can play with Pinocchio yourself. So we can all become pro Solana devs. Yay! Give this video a like if you want to be a pro dev. Make sure you are subscribed and then go watch those videos if you're still in the mood for watching videos. If you are in the mood for going out to program some, go do that. I encourage you to code yourself and not just watch a random guy on the internet talk about coding, because you will only really learn if you do it. Do it, at least think about it a bit yourself as well, because that's how you learn. Okay. Cool. And that's the goal, right? We want to learn how to that's the whole, but why are we here? That's why. Okay, good. Glad that we established that. All right, cool. I'll see you in the next video where you can learn some more.